All right, so good morning again to everyone. Um, we're going to be starting class now. So, what are we doing today? As I told you guys when we were in school last week, we already covered these five chapters here. Chapter 1.1 Basic Computer Components, Input Devices and Media, Output Devices, Primary Memory, and Secondary Storage. So, this term we'll be completing the other six chapters. So today we'll be starting with system software. So if you guys can remember, when we were looking at software, there were two types of software. There was application software and system software. So if you notice, there are two chapters that are specifically for those two types of software. So we're going to be getting into more detail as to what the system software is about and why is it used, what are the different types, what are the functions, and so on. All right. So to get it started, Akila, can you read the first two paragraphs for us?
System software is the main unit of software that controls hardware and how all other software works. Example of system software include operating systems and utility software. Operating system. The most commonly used system software is called an operating system. Without an operating system, a computer would not work. Popular operating systems include Microsoft Windows 10, Apple Mac OS X, and many versions of Linux. Popular mobile operating systems include Apple iOS and Google Android.
Very good. So let me get paint. So as I told you guys already, we have software at the top here, and then we're gonna branch off with system software, and then we have application software. So on the system, we would have operating system and utility software. So on the system, you're gonna have one, the operating system, and two, utility software. So that's for first focus on what is the system software. So as the definition here indicates, system software is a name given to the software that controls hardware and how all other software works. So you have your hardware. We already learned what is hardware. We learned that hardware is the physical parts of your computer, the keyboard, the mouse, the CPU, the monitor. So this software, the system software, controls all of that hardware. System software controls your keyboard, controls your mouse, controls your trackpad, controls your screen, whatever the case may be. It controls all of that hardware. And if you notice, it controls other software. Can anyone tell me what's the name of the other software that you think you'd be controlling? What's the other software do you think it would control? No one? Well, it's actually going to control the application software. So the system software is for the system. It's going to be controlling the system, controlling the hardware, and it's going to control all other software, which includes the application software that is going to be running on your computer. So that is the definition of a system software. It controls your hardware and it controls how our software works. So you can think about it, when you start up your computer, that system software needs to start up. When you start up your phone, that system software needs to start up. Software is always starting up, whether it's Android, whether it's Windows, whether it's Mac OS. It's always going to be some sort of system software starting up. And until that system software starts up, only then will you be able to use any other software. Only then would you be able to use the application software. Your camera, your phone app, Google Chrome, whatever the case may be. And as mentioned, there are two types of system software: your operating system and utility software. So what is the operating system? The operating system is most commonly used system software. Is the most commonly used system software. I mentioned this last week, that even though system software, it has two types, operating system and utility, because the operating system is the most used, is the most dominant. When persons talk about system software, they're usually also referring to the application, the operating system. So they sometimes are interchangeable, but it also refers to the utility software. So for system software, the operating system is the most used because that's what's running your entire computer. And some common examples of operating system: Microsoft Windows 10. Notice the full name: Microsoft Windows 10, Apple Mac OS X, Linux, and the other one is Unix, UNIX. Those are some common desktop-based operating systems. And for mobile operating system, you have Apple iOS, Google Android. Anybody remember what's the other examples? What are the other examples of mobile operating system?
Sir, Amazon Fire OS.
Very good. Amazon Fire OS. Anyone else? So Amazon Fire OS, Google Chrome OS, Harmony OS. Those are some other examples of mobile operating system. But most common ones are going to be Apple iOS, Google Android. So what we're going to look at next is basically the functionality of the operating system. So let me zoom out a bit. So the rest of these headings that you're going to see here, they're basically functionality of your operating system, what your operating system does. We're going to learn what is booting, what is mean by the term booting, and how your operating system carries out hardware control, software control, or you can reverse it. We're going to be learning how does your operating system control the hardware? How does your operating system control the software? How does your operating system manage memory? How does it manage input and output? How does it manage process? How does it manage files? So that's what we're going to be learning more about the operating system. But firstly, we're going to be looking at booting. What is booting? Anybody ever heard that term before? Booting?
Yes, sir.
And when you hear booting, what comes to mind?
Sir, like turning on the computer, booting up the computer.
Very good. That's exactly it. So booting refers to starting up your computer, turning on your computer when your computer is actually turning on. So what we're going to be looking at is what actually happens when your computer is turning on. What happens when you're booting your computer? All right, Amelina, could you read for us?
Booting. The process of starting a computer is known as booting. The first thing a computer does when you turn on the power button is to check that it is working properly by following certain instructions held on a ROM chip known as the BIOS. It will then look for an operating system to tell it what to do next. The operating system is loaded from disk to the computer's random access memory RAM.
Very good. All right, so I'll be giving you guys a diagram of how your computer um, boots or how it starts up. So obviously your computer needs to be plugged in. So this is the outlet over here. This is your outlet. So this is a cable running to your outlet. So it's getting power there. And right around here, we're gonna have a power switch. So let's go back to paragraph and take it into pieces. So the process of starting a computer is known as booting. So that's important to remember. What is referred to as booting? It's a process of starting your computer. How does your computer start up? Well, that process, the first thing a computer does when you turn on the power button, is to check that it is working properly by following certain instructions held on a ROM chip known as the BIOS. So, let's see. So I'm going to draw a motherboard. So this is the system unit. System unit. The case. This is the motherboard. This is the CPU here. This is the RAM, memory. And on the motherboard, that's where you're gonna find the RAM chip. So I'm just gonna put it like around here. So this is your BIOS, and over here I'm just going to make a connection to a hard drive. Your hard drive is at the bottom here. This is your hard drive, and your operating system is on it. So Windows 10, Windows 11, this is where that operating system is located. So you're also gonna have a monitor, keyboard, a mouse, what else? Maybe some speakers, and inside here would have some other stuff. So what is booting? How is booting carried out? So as the paragraph mentioned, the first thing the computer does when you turn on the power button, so that's the first step The first step is pressing this power button here. Pressing this power button. That's how everybody turns on their computer. You press a power button. So someone presses this power button over here. Now, whenever you press that power button there, what happens next? You turn on the power button is to check that it is working properly by following certain instructions held in a RAM chip known as the BIOS. So from the power button, it's going to go to the BIOS. So you press that power button and current is going to flow to the motherboard, and then basically the BIOS chip is going to turn on. So that's the second step there. That's going to be number 2. So it's basically going to power up this BIOS chip, and it's going to run what is on the chip. So some instructions are going to be on the chip. What are these instructions? If you notice, the instructions are right here in the paragraph. It checks to see what is working properly by following certain instructions held in that BIOS. So that BIOS has instructions inside of it to check your entire computer to know if it is working. So what it's gonna do, that BIOS there, it's going to go to the RAM, check to see if it's working. Are you working? It's going to go to the CPU. Are you working? It's going to go to the mouse. Are you working? It's going to go to the keyboard. Are you working? It's going to go to your hard drive. Are you working? It's going to do that for all of the devices. Are you guys following on what the BIOS does?
Yes, sir.
Alright, so the BIOS is gonna have instructions to test all of your computer parts to ensure it is working. Now, have any of you ever heard when you're starting up your computer a beep sound?
Yes, sir.
Well, you're only gonna hear it if you have a desktop computer. You're not gonna hear it if you have a laptop. But if you have a desktop and you start it up, you would hear a beep sound. That beep sound basically means that your computer, the BIOS, has finished checking everything and everything is working. That's what that beep represents. So that there is the second part. You press the power button, the BIOS basically starts up, and it checks it to see if everything is basically working. Now, once everything is working, the operating system needs to take over now. The operating system needs to take over. So it will then look for the operating system. So it's going to look for the operating system. So what is it going to do now? It's going to change the color there. From the BIOS chip now, it's going to finish checking, and then it's going to go to your hard drive. And it's going to look for the operating system. And when it has found that operating system, can anybody tell me where do you think the operating system will go? So the operating system has to go somewhere in order for it to work. Where do you think that is? Look at the parts that you have on the screen right now. Where do you think it has to go? It's something we actually learned about already. Where does everything have to go in your computer in order to work?
Sir, the CPU.
Okay, go try. Well, it's actually the memory. So yes, it has to go to the CPU to be processed, but remember, the CPU is only going to process what is inside of memory. So it has to go to memory first. So the operating system is going to be loaded into memory. So that's number 4 there. That's the fourth step there. And then it's going to go over to the CPU. It's going to transfer over to the CPU in order for it to be processed. So that's basically how your computer starts up. Let me see if the paragraph has more information. The operating system is loaded from disk. Notice it's right here also. The operating system is loaded from disk to the computer's random access memory. So the RAM refers to basically memory. So we also call memory RAM, which stores the instructions for the CPU. So whatever your computer needs to run, whatever your computer needs to instructions it needs to run, basically, whatever your CPU needs to see in order to function, it must be inside of this memory here. It must be inside of RAM. So it has to go to memory first, then to CPU. So in review of booting, booting basically means that your computer is starting up, that your computer is turning on. So it's a process. And what is that process? Well, when you press the power button, the electricity is going to flow to the motherboard, and this BIOS chip is going to start up. The BIOS chip is going to check all of the devices that you have on the computer, make sure everything is working, and once everything is working, it's going to look for the operating system on your hard disk, take that operating system, load it into memory, and then the CPU is going to process that operating system. It's going to run that operating system, and that's where you see your Windows is starting up, or your phone is starting up, because the data is being sent to memory and the CPU is basically processing it to start it up. Are you guys clear on that?
Yes, sir.
Anybody wants me to go it over, or are you guys clear? All right. So moving on, what is hardware control? So as mentioned, we're going to be looking at what your operating system does. How does your operating system function? So one functionality of your operating system is to control hardware. So how does your operating system control hardware? Balkasoon, could you read that paragraph for us?
Hardware control. The operating system supports tasks like accepting input and transferring data between primary and secondary memory, or displaying output. It also sets the rules for controlling hardware resources, such as per- peripheral devices like keyboard and mouse, the amount of memory used, CPU, time allocation, and hard disk space.
Very good. Good. So, how can you understand hardware control? First, you need to understand that your computer has a lot of hardware. Your hard drive, your memory, your CPU, your keyboard, your mouse, your speakers, your monitor, your CD drive. Those are all hardware that are attached to your computer. And for each one of those hardware, something wants to use it either as input or output. So for example, your mouse, something wants to use it in order for it to function. Your keyboard, some sort of software is going to use it for you to type inside of it. Your CPU, your CPU is constantly needed by your computer. Every software running on your computer needs the CPU to process something. So who gets access to all of this hardware? Who controls when the keyboard should be used, when the mouse should be used, when the speaker should be used, when the hard drive should be used? That is the operating system. The operating system controls who is going to use the hardware, when they are going to use that hardware, and for how long are they going to use that hardware. So who, when, and for how long they're going to be using that. So think of the operating system like what? Like a police. That's basically saying that look, only the keyboard could use this software at this time. Only the mouse could use this software at this time. Or the operating system acting like the police is gonna say that how let's see, for instance, we have a list of programs. We have Google Chrome, we have Word, and we have Paint. And all of them needs to use the operating system. So what the CPU. Remember, the CPU is hardware. So what the operating system is going to do is going to tell them, look, y'all line up. Google Chrome is going to go first, Word is going to go second, and Paint is going to go third. So when Google Chrome finish, then Word could go. When Word finish, then Paint will go. So that's what your operating system is doing all of the time. It's even doing it right now. It's saying who can use the what resources for how long and when they can basically use it. Are you guys clear on that?
Yes, sir.
All right. So next we have software control. Darshana, could you read for us?
Okay, sir. Software control. The operating system controls how all software applications, games, or other programs work on the computer. Memory management. When a program or data is too large to fit into main memory, a method called virtual memory can be used to split the program into manageable blocks. The required blocks are swapped between main memory and secondary storage to accommodate the program or data.
Very good. So, software control, as mentioned already, your operating system controls how all other software works. So, that software is the application software, the softwares that you are gonna use on the operating system. So, for example, your games, your programs, like how I'm using Microsoft Edge, Chrome, Paint, Word, those are all being controlled by the operating system. So you can think of it like it being in layers. You have your this layer here is your operating system, and this layer here is going to be your application software. So 1, 2, and your hardware is going to be at the bottom here, hardware. So the hardware is here, your keyboard, your mouse, and the next level is going to be your operating system. So your hardware, you cannot use application software without having an operating system. Similarly, you cannot use application without the hardware, vice versa. You cannot jump from that layer to this layer here, basically. You must have the operating system running in order to be able to use the application software or even use the hardware. So the operating system is basically the middle person connecting the application software and the hardware. So the next aspect of your operating system is memory management. So how does your operating system manage memory in your computer? So what memory are we talking about? We're talking about RAM. Remember we just learned about booting? We talked about that memory that is right beside the CPU that holds all of the instructions for the CPU to be carried out. That is what we're talking about. RAM, memory, who manages it? Who manages what can go into that memory, how much, and for how long? Once again, it is the operating system. So this here is your CPU. And over here is going to be your memory. This is just a representation of it. So remember, as mentioned, your memory holds what your CPU is going to process. So data is going to be constantly going back and forth between the two. So this is your memory or your RAM. So inside of here now, say for instance, your memory is going to have a size. Any of you that using a computer right now, or even your phone, what are some common sizes of memory that your computer has? Or does anybody know what I'm talking about?
So 4, like for,
4?
for like a phone.
Okay, so you're running a 4 gigabyte memory. So for those who don't know what I'm talking about, if you're running a computer right now, you could go to Start, and you can go to Settings, and Settings is going to come up, and you could go to System, and you could go to About, and it's going to tell you the information about your computer. So if you notice, my processor or the CPU, so this processor is my CPU. So I have an AMD Ryzen 7 2700U with Radeon Vega Mobile GFX and so on. Now the RAM, how much RAM do I have? I have 12 gigabytes of RAM. So your RAM is going to have a certain amount of size on your device, and that, just like your flash drive, just like your hard drive, it can only hold so much data. So for example, we're going to use a 4 gigabyte as an example. Today 4 gigabyte is actually small to run a computer. Now inside of your memory, what is going to happen is that your applications are going to be stored in memory for your CPU to process it. So we can divide it up. We can say, for instance, this is going to be used by Word, and say for instance we have Chrome. We know Chrome does take up a lot of space, so this is going to be Chrome. and then maybe we have Paint open. So that's Paint, and any other applications that we have open there. So this is basically what your computer actually looks like when applications are going into memory, when your software is going into memory. It takes up the space like this here, and the CPU is going to basically go over and say, give me these instructions for Word, give me these instructions for Chrome, and then process it. So what we're looking at now is memory management. How does your computer manage the memory? Because if you have a small amount, then when you try to run large programs, it won't fit into memory. So notice I have these applications open, but then if I decide to open another application or 3 or 4 more applications, it might not fit into memory. So what happens there? Who says who can go into memory, or who stays, or who gets put out of memory? Well, that is the operating system once again. So when a program or data is too large to fit into main memory, a method called virtual memory can be used to split the program into manageable blocks. Now, if you notice, we have another term here, main memory. So there's actually 3 names that we can refer to memory. We can call it memory, we can call it main memory, or we can call it RAM. So there are 3 names that we can refer to that memory: memory, main memory, or RAM. So when data tries to go into that main memory or that RAM and it's too large, we have to use a method called virtual memory. And what does this word virtual mean? Anyone? What does the word virtual mean? Or what comes to mind when you hear virtual? Is it something real or is it something not real?
Sir, it's not physical.
Right? It's not physical. Or something that's online. Okay. Or something that is not real. So something that is virtually created, something that is created online, something that is digitally created. So it's not actually physically real. So this virtual memory refers to memory that you create virtually, that you create digitally. It's not physical, like how this memory here next to your CPU is going to be physical. This virtual memory, not physically existent, such as made by software to appear. So, yeah, that's a good definition there. It is made by software to appear as it is existing. So that's exactly what will happen. Software is going to make it as though this memory is existing, this virtual memory. So when your computer runs out of memory, it uses a method called virtual memory, because it's important to understand that your computer needs memory in order to function. Remember, that's how your CPU gets its instructions. Whatever is in memory, that is what your CPU is going to process. If it is not, it won't work. It won't be able to process anything. So you must always have something in memory in order to have your CPU work. So that's why we have virtual memory. So when your physical memory, your RAM, is too small and you want to basically open more applications, it's going to use the virtual memory. So what it's going to do, the virtual memory can be used to split the program into manageable blocks. So what it's going to do, let me erase that. So what it is actually going to do, let me so say at the bottom here, this is your virtual memory, VR, virtual memory. So what it's going to do now is that you want to open a very large program. Say for example, Adobe Photoshop. I'm sure all of you heard about Photoshop. It's a large program. So what's going to happen now, Photoshop is going to open, but it cannot fit inside here. It cannot fit within this space here. It's going to extend it out. So what it can do now is that it can take this paint here, this paint that I have here. You can take this paint and let me use a color that you guys can see. You can take this paint and transfer it to virtual memory. So paint is going to take up here now. So that extra space there now is where your Photoshop can take up now. So it basically swapping the what is inside of the physical memory with what is inside of virtual memory. Because even though you have this virtual memory, your CPU is not going to work with it. It's not going to work with it. It has to use the physical memory. So your operating system is going to try to take out of the physical memory what you're not currently using. So if I'm not currently using Paint, it's going to take it out of the physical memory, put it into the virtual memory so that it has space for anything else that they want to open. And that way now, the Photoshop is going to take up all of the space. It's going to fit nicely inside of the physical memory, and the CPU is going to see that and process it. Yes, Johannes?
Sir, but since if you don't have the amount of RAM, right? What program, since it has to do all that now, since it doesn't have the sufficient amount of RAM for the program, would it run smoothly?
No, it would not. And have any of you ever noticed that if your memory is small and you try to run a lot of programs, what actually happens?
Sir, it would stick up and be...
Exactly. Because yes, the method exists. The method exists for you to swap between physical memory and virtual memory, but it's not that of an effective method to make your computer work properly, because your computer needs physical memory in order to function properly. It cannot work with this virtual memory as I just indicated here. So if your physical memory is full, that is where you're going to notice your computer started slowing down. It's going to freeze up, it's going to stick, because it needs that open free memory, physical memory, in order to run smoothly. And you can actually check it on your computer. If you right click on your task bar at the bottom here, you're going to see Task Manager, and then you could go to Performance, and then you click on Memory, and it shows you how much memory you're using. So currently I am using out here it shows 4.8, at the bottom here 4.6, and let's see, hashed 2.2 available. Yeah, so it's showing me how much memory is in use, how much I have free. So my computer is working relatively okay with this amount of memory usage here. So if you ever see that your computer is moving slow, it could be one of two things. Either that the CPU, it is processing very high. This chart here is all the way at the top, so it can't handle all the instructions. Something is causing it to handle one specific instruction, and that's what's taking up all of the time. So your computer is moving slow. Or your memory is actually full and it can't work with any other program or software. So that there is memory management. Let's see. Any other questions on memory management? Oh, here's a question. Where do you guys think this virtual memory is going to be located? This virtual memory that we're going to create here. Why am I not seeing my cursor? This virtual memory that we're going to create here. Where do you guys think it's going to be located virtually? Well, it's actually going to be located on your hard drive. So this virtual memory is actually going to be created virtually on your hard drive. And your hard drive, we would have learned that your hard drive is slower than memory. So that's why even though you have this virtual memory, it's not going to work as effective as having physical memory, because it's still on your hard drive, which is slower than that memory. Now the paragraph also says that the required blocks are swapped between main memory and secondary storage. So that secondary storage is your hard drive to accommodate the program or data. So that's what virtual memory is. It creates a virtual RAM or a virtual main memory, and that is located on your secondary storage. It's located on your hard drive. It can even be located on a flash drive, and the programs are swapped between main memory and that virtual memory. That is memory management there. Now we also have input-output management. Gabrielle, could you read for us?
Yes, sir. Input-output management. Since each device has a program called a driver, sorry, sir. Since each device has a program called a driver that allows the device to communicate with the computer, the flow of information among devices must be managed and coordinated.
Great. So we need another diagram for this one here. All right. So this is your computer. This is the CPU, the motherboard, system unit, CPU, memory. So the operating system is going to be inside here. Now you're going to have devices connected to your computer. So your monitor, your keyboard, your mouse, your speaker, and the operating system is going to be communicating with all of them. So your operating system is going to communicate with the keyboard, communicate with the monitor, communicate with the speaker. So what it needs to do now, since each device has a program called a driver, now this is important to remember. A driver is a software that helps your operating system to communicate with the device. So between all of this here, all of this connection here is going to be a driver. which is a software. So think of this driver like a translator. Your speaker, your monitor, your keyboard, your mouse, they're speaking a different language compared to your operating system. And who is going to translate those two different languages? Who is going to help them to communicate? That is where the driver comes into play. So the driver allows you to communicate with your devices. And if you ever notice that on your computer, when you plug in a new device, it would usually say driver has to be installed.
Yes, sir. When
Right.
I plug in one any devices.
Right, exactly. So whenever you plug in a new device, it doesn't work right away because it has to install that driver in order for it to function. But after that, you can continue. You could use it as soon as you plug it in because the driver was already installed. But if the device fails or something happens to it, sometimes you might see an error pop up, driver not found, and that's an indication that it's not the computer is not being able to communicate with the device. So driver allows the device to communicate with a computer. The flow of information among devices must be managed and coordinated. So your operating system is going to control who gets to use the speaker, who gets to use the monitor, who gets to use the keyboard, who gets to use the mouse, even your hard drive. Your operating system is going to be controlling all of those input and output devices. Well, hard drive is storage. So it's going to be controlling who basically gets to use what and when. Next, we have process management. Katrina, could you read for us? Leancia? Leroy?
Process management. Process management allocates time for processes to use the CPU, checks on progress waiting to use the CPU, checks on processes waiting to use the CPU, and signals when the CPU is available.
You can read the other one also.
File management. Files need to be saved, copied, renamed, and deleted. A file manager checks the amount of memory needed to perform these tasks and manages the organization of the files in the secondary storage.
Very good. So we're looking at process management. Now, what can help you to remember process management is to remember that the word process actually means program, but it's the location of that program. So let me recreate the so once again, this is your CPU and this is your RAM. So this is your RAM, and inside of it, once again, you're gonna have some programs, Word, Paint. Just remember, your CPU needs these programs in order to process them, and whatever other programs. Now, where are these programs located? They're actually located on your hard drive of your computer. So these programs are pulled from your hard drive. So the programs, they are pulled from your hard drive and then they are stored in memory for your CPU to process it. So programs come from your hard drive. You open the program, you open Need for Speed, you open Grand Theft, you open Word, and it goes into your RAM. And then your CPU is going to see that program so that it can process it. Now, what are we looking at? We're looking at process management. Process management allocates time for processes to use the CPU, checks on processes waiting to use the CPU, and signals when the CPU is available. So at the bottom here in your hard drive, they're going to be called programs, and inside of RAM, they're going to be called processes. So your CPU now, the operating system, is going to check to see if the CPU is available. If it is available, it's going to send over Word. It's going to say that, look, Word is available right now, you can process Word. Then if it finishes processing Word, it's going to say, look, Paint is up next, process Paint. So your operating system is basically going to control who gets to use your CPU and at what time. That is called process management. What gets processed, when, where, and how, basically. You guys clear on that? So the final functionality of the operating system is file management. So file management refers to saving files, copying files, renaming files, deleting files, checking how much memory is needed to carry out tasks, organizing files. That is all part of file management, which is part of the operating system. So whenever you go to a file and you right click on it and you copy it and you go to another location and you paste it, that is file management. Your operating system did all of that. When you right click on a file and you go to rename and you change the name, your operating system is carrying out that also. File management. When you delete it, that is all part of your operating system. And that is file management. So the last topic, utility software. Nicasia, could you read that for us?
Yes, sir. Utility software is specialized software that tries to protect and maintain the system software. Examples include protecting software against damage caused by computer viruses, backing up files, and recovering files after software has stopped working or crashed.
Very good. So remember we learned that for system software there are two types. So we just completed operating system, and now we're looking at the other type, utility software. So what is the utility software? It is specialized software, and the aim of that software is to protect and maintain the system software. So that's like its guardian. It's protecting it and maintaining it, ensure that it is working properly. So what are some examples of utility software? Well, basically software that protects you against viruses, software that allows you to back up files. If you accidentally delete a file, you can use a software to recover that file. That is also a utility software. Any software that basically allows you to ensure that your operating system is running smoothly, it's running properly, it is a utility software. So these questions here, let's see. I'm gonna make it as a homework in your in Google Forms once again. So you guys gonna look out for that. So in review, what have we looked at today? We looked at what is a system software. It is basically software that controls both hardware and all other software. There are two types: operating system and utility software. We looked at what is an operating system and what are some examples of desktop and mobile operating system. We looked at what is booting. Booting basically means your computer is starting up, but it is a process. So what is the process? You press the power button, the BIOS carries out its instructions, the operating system is loaded into RAM, and then your operating system starts up. Your computer starts up. What are some functions of the operating system? It controls the hardware. It controls who, when, and how long software can use the hardware. Software control, it controls what software is being used. Memory management, it manages who can use RAM, who can use the main memory, for how long, when, and so on. Same for input-output management, who can use the input devices, when can they use the output devices, and so on. And we looked at what is a driver and what is virtual memory. Then we looked at what is process management, which is basically managing programs that are inside of RAM. And then file management, which deals with your operating system managing what gets copied, pasted, and those things. And then lastly, the other type of system software, which is utility software, which basically supports the system software. It helps to protect and maintain it. Alright, any questions before we close off?
No, sir. No, sir.
Alright, so if you guys don't have any questions, that's the end of today's class. Enjoy the rest of your day.
Yes, sir. Good.